I want to use my trigonometric formulas to do a few more examples, but not with actual angles given. When we have an unknown angle, we have some key information about that angle. So we're going to look at some examples. We're going to find the exact values given, and we're going to take this set of conditions for our problems. Sine of alpha is equal to 4/5, tangent of alpha is less than 0, cosine of beta is equal to -2/7, and cosecant of beta is greater than 0. So let's start with the problem. Let's try to find sine of alpha plus beta. Now the problem with this is we know nothing about alpha plus beta. I know where alpha is, I know where beta is, and we can't just split these things apart. We talked about that in the last video. If I know that alpha is here and say beta is this angle, well, if I add those together, chances are it's actually going to look something like this or be very close to that y-axis. So completely different x and y coordinates than the initial two positions. So I need to express this in terms of more simple alphas and betas. But I can't just say sine of alpha, sine of beta, but I can use my formulas. So I know that I can write this as sine alpha cosine beta plus cosine of alpha sine of beta. Well, that's better. I've worked it down to more simple angles because I knew nothing about alpha plus beta, but I do know some things about alpha and beta. The problem is, though, still that I don't know what sine of beta is, and I don't know what cosine of alpha is. I only know sine of alpha, cosine of beta. But I do know that much about it. I know that sine of alpha is equal to 4/5, and so what that allows me to do is to think about that in terms of a triangle. I don't know what alpha, the angle, actually is, but I know the triangle around it. I know the opposite has to be 4. I know the hypotenuse has to be 5. And so this one's pretty easy. I know that missing piece has to be a 3. It's a 3, 4, 5 right triangle. But one thing I want to be careful of is I don't know what quadrant this is in. I don't know its sign yet. I see that sine is positive, meaning it could be in the first or second quadrant. Tangent is negative, however, which tells me that alpha must be in the second quadrant, which means this x value there has to be a -3. I do the same exact thing for beta. I'm not drawing these things for proportion. Cosine of beta, I don't know what beta actually is, but I know the adjacent has to be equal to 2. I know the hypotenuse has to be 7. And because cosine is negative, that could be in the second or third quadrant. Because cosecant is positive, that has to be in the second quadrant. And so that tells me that the x will be negative, but the y will be positive. I know that's why whatever we find will be a positive. So this one is not quite as easy as the last one. It's not just 3, 4, 5 right triangle, but I can use my Pythagorean theorem to figure it out. -2 squared plus that unknown y squared equals 7 squared. So I'd have 4 plus y squared equals 49. And subtracting that 4 over, y squared would be equal to 45. And when I take the square root of 45, remember we'd have to put a plus minus in front of it, other than the fact we just figured out this was in the second quadrant as well. They're both in the second quadrant. Makes it a little bit easier. So I know that this will be a positive, and I can simplify that square root to 3 root 5. And so now I know all the pieces of my triangle, so I can figure out sine, cosine, tangent, cosecant, secant, or cotangent, whatever I need. In this case, we just need the sines and the cosines. So sine of alpha, this was the given. This was the 4/5. The cosine of beta, this was also given. We had both of those two things right at the start. That's a -2/7. Is the second set of terms that I had a little more difficulty with, or at least I had to find. Cosine of alpha would be the -3 over 5. There's a 3. And then, let me clean that up. Then the sine will be pretty easy now that we have our picture drawn out. The opposite would be the 3 root 5, and the hypotenuse is the 7. And so there are my fractions. If I multiply these together, I get 8 over 35. I get a -9 root 5 over 35. And then because we have the same denominator, we can add these things together. Now that the numerators aren't like terms, but I can at least put it as a single fraction. So there's my answer. 8 minus 9 root 5 over 35. That's all we can do with it. So I could do the same thing for cosine. I could do the same thing for tangent. Let's do cosine real quick. Cosine of alpha plus beta. So here we're going to have cosine alpha, cosine beta, minus sine alpha, sine beta. And cosine of alpha we just found a second ago to be the negative 3 root 5. Cosine beta was given as the negative 2 over 7. Sine of alpha, we were told it was the 4/5. And then sine of beta, we just found it to be the 3 root 5 over 7. Now, I did mean to point out the last case, and it's still true here. One of the most common mistakes I see will be people leave the cosines on these. We can't leave the cosines and the sines on these things. That would be completely wrong, because the alpha is the angle, not the 3/5. Once we've found the 3/5 or the 2/7, we have found what the cosine's value is. That would be like if you told me the square root of 9 is equal to the square root of 3. Now, we've already done that calculation. We don't need to leave the function on it. We've done it, and so we're going to take it off completely. So we want to make sure we're getting rid of those sines and the cosines once we've actually evaluated what the alpha's ratio of sides is. Once we get to those ratio of sides, that is gone. So now I'm going to multiply them together. I get 6 over 35 minus 12 root 5 over 35. So we could put it together as 6 minus 12 root 5 over 35. I'm going to do the tangent really fast, because that one's very easy if we have sine and cosine. So remember, there is a sum formula for tangent. We have tangent of alpha plus beta. Going back up to my list of formulas, we can see that we could take tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta, and that would work. But anytime you have the sine and the cosine, which we do now, tangent, the easiest way to write it is always sine over cosine. It doesn't matter if the angles are looking weird, as long as the angles are the same throughout. And so we found sine to be the 8 minus 9 root 5 over 35. The cosine in the line directly above, 6 minus 12 root 5 over 35. Well, rather than dividing, I could have also thought about this as multiplying by the reciprocal, which is much easier to do, and we will need to do at some point. And so here, because the 35s are there in factors, I can cancel the 35s, and that leaves me for a final answer, 8 minus 9 root 5 over 6 minus 12 root 5. And so that would be our answer. Let's apply a different formula. So I want to look at cotangent of 2 alpha. We haven't talked about tangent at all yet in terms of the alphas and betas, and we haven't done cotangent as well. And notice we don't even have a double angle formula for cotangent. This is one of those that we're going to have to think about its reciprocal first. So cotangent I know is 1 over tangent. So if I consider tangent of 2 alpha, if I find that, then I can purely take its reciprocal. So I'm not going to write an equals to the next one, but I am going to just look at tangent of 2 alpha first, and then we'll find its reciprocal for our last piece over here, and this will be our answer. We'll find that in just a second. So the tangent, what we did just a second ago is we used sine over cosine, but because I haven't found the double angle of sine over cosine, or if I haven't found the double angles for sine and cosine yet, I'm going to just jump right into that tangent formula. So we have 2 tangent theta over the in this case the theta being the alpha, it is important to note that we have the angle, over 1 minus tangent squared of alpha. Remember, this formula comes about through the sum and difference, so we could have also started with sum and difference, just adding the thing to itself, but if we have the double angle, we have twice the angle on top, 1 minus the tangent squared on the bottom. So we do need to know in this case what tangent of alpha and beta is. We haven't found these yet, so let me scroll up to the alpha triangle. Really, we only need the alpha. Well, tangent is the opposite over the adjacent, so we have 4 over negative 3, and it will be a negative because we were already told that tangent is negative. Remember, always pay attention to those signs. Have negative 4/3 here. And then in the denominator, we'll have 1 minus negative 4/3 squared. So let me just start simplifying these. We'll get negative 8/3 on the top. And then on the bottom, we'll have 1 minus, because the negative inside the squared is going to square out, so we'll have a 16/9 there. This would be a case where I want to get rid of my fractions and fractions, so I'm going to multiply by the common denominator across the whole fraction, which is 9. If I multiply the 9 on the top, the 3 goes into 9 3 times, and so I have negative 24 on top, canceling out the 3, still have 3 to multiply to the 8, over, multiply the 1 by 9, we get 9 minus 16. Some simplification that can take place there, get negative 24 over a negative 7, and of course the negatives drop out, giving us 24 over 7. And we can't simplify that anymore, so that would be our answer for the tangent of 2 theta. But, of course, we wanted to know cotangent, so we could write it as the 1 over, or we could just flip what we had, so that means the 7 is going to go on top, and the 24 will go on the bottom. And that is our answer. I'm not going to do any examples with the power reducing because, for the same reason we said before, if we see sine of alpha squared, well, we know what sine of alpha is. That was the 4/5, and so we can just take that and we can square it. 4/5 squared would be 16/25. So those are very easy. I do want to do a couple more with the half angle and make sure we're comfortable figuring out what the sign is in front. This time we want to find the exact values again, given cosecant x is equal to negative 3 and tangent x is less than 0. And I want to find sine of x over 2. So if I look at this, what do I know? Well, I know some things about x. Right, this is giving me enough information to draw a triangle around x and see what the sides are. So the opposite side would have to be 1. The hypotenuse has to be 3, because remember cosecant is equal to the hypotenuse over the opposite. And one of those sides is negative. The hypotenuse is never negative. So what that's telling me is that the y is going to be the negative. Or another way to think about this is to think about which quadrant it's in. Remember, that's always very helpful. Think about quadrants, think about your signs. If cosecant is negative, that occurs in the 3rd and the 4th. Tangent is also negative, that occurs in the 4th. So this thing is in the 4th quadrant, which means that the cosines, secants, the x's are all positive. The x sides, the base here, would be positive. So I'm going to figure out this 3rd side using my Pythagorean theorem. So we'd have 3 squared minus, we call this 3rd side, we'll call it a for right now. Square root of 3 squared minus the negative 1 squared. Remember, we have to square that entire negative 1, meaning it's going to become a positive. So we get the square root of 8, which is 2 square roots of 2. Okay. So we now know this bottom side here is 2 square roots of 2, and it is going to be positive because it is in the 4th quadrant. So we'd look at this and we'd say, well, sine is going to be negative 1 over 3. Great. We're not interested in sine. We don't care about sine of x. We care about sine of x over 2. I don't know what x over 2 looks like. I can't just say, well, if sine is equal to negative 1 over 3, I'm going to take half of that and get negative 1/6. That's completely false. We can't just say that sine x over 2 is equal to 1/2 sine of x. That is 100% false. That is not how functions work. That's never how functions work. This is, again, where our formulas come in. We have to apply a formula. And our half angle formula, because that's what we're doing, we're taking half of the angle. Our half angle formula tells us that we need to take positive negative square root 1 minus cosine of x over 2. And how do I know this? We have this on our formula sheet. Again, these are formulas that we really do want to memorize by the time we get to calc. These are ones that, for right now, we're just kind of looking at our formula sheet. And so we're obviously comparing this to the sine half-angle formula, and this is the formula that we get. From this formula, we now have an angle of just x. We can now use this right triangle that we drew out at the start where we couldn't at first because we didn't have the x over 2 triangle. With these half-angle formulas, I said this before, but I'm going to stress it, we can never leave this plus minus here. We have to make a choice. We are never going to use both. We do not use both. So what I'm going to think about is where this thing is. I know that x is in the fourth quadrant. We said that at the start. That means that x is between 270 degrees and 360 degrees. Not inclusive, has to be strictly between them. So if I'm curious about x over 2, if I want to retain the inequality's truth, if I want to retain the inequality, I can divide all sides by 2. So x over 2 has to be between 135 and 180. And that means that x over 2 is in the second quadrant. So what we've done here is we've started with this original angle. It's somewhere in the fourth quadrant. We're not sure exactly where. What we're saying is, let's take half of that original curve. And so when we do, it places us somewhere to the second quadrant. We see that right here. And so that's how we're going to choose that plus minus in front. I want the sine of half of the angle, meaning I'm back into the second quadrant. That means I'm going to have to choose the positive. You don't have to write the positive there, but it is important to note we are going to make that choice. We are never going to leave the plus minus in front. Then we have our square root. We have 1 minus. Now we need to figure out what cosine of x is. Cosine of x is the adjacent over the hypotenuse, so the square root of 2 square roots of 2 over 3. And we're going to divide that by 2. Cosine was in the fourth quadrant, and how do we know that? Because x was in the fourth quadrant. So we're looking at two different things here. When we're looking at that outside sine, we're looking at what is the sine of this thing right here. What is this angle right here, and where is it? When we're looking inside, here it's asking for cosine of x. We knew that x was in the fourth, and so in the fourth quadrant, cosine is positive. The negative leaves it negative. From here, I'm just going to do a little bit of simplification. I want to get rid of the fractions and fractions. So I'm going to multiply top and bottom by 3. I'll have 3 minus 2 square roots of 2 over 6. And that's it. That's my answer. There we have it. Let's take another example. Let's take the secant of x over 2. We're going to approach it in a very similar way. We know a lot of things about x. We know that x was into that fourth quadrant. We know what the ratio of sides looks like built around that x. We still know that x over 2 is in the second quadrant. But we're going to have to use a different formula because we're not dealing with sine. So very much the same ideas, different formulas. If I think about secant, we don't see a secant half-angle formula, and that's fine because we know what secant is in terms of cosine. Secant is 1 over cosine, and so if we have secant of x over 2, it's equal to 1 over cosine of x over 2. We know that cosine of x over 2 is plus or minus. Again, that plus or minus is there. We're going to have a decision to make. We're not going to leave both. 1 plus cosine of 2x, just x, double what the angle started as. 1 plus cosine of x, doubling the x over 2, all over 2. Now this is kind of awkward. You have a fraction within a fraction, but remember when we have fractions and fractions, you can just multiply by the reciprocal, so we'd get the square root of 2 over 1 plus the cosine of x. So yes, on our formula sheets, we don't have any formulas for secant, cosecant, or cotangent. But because we know what the double angle, sum and difference, half angles, product sum, all those different formulas, we know them for sine, cosine, and tangent, we can get to the secants, cosecants, and cotangents using their reciprocal identities. All right, so from here we need to make the choice of that plus minus. Let's actually apply this formula to our problem. So I have that choice of plus or minus. Well, secant, cosine, right? Secant and cosine, we need to think about that half angle. We said that the half angle is in the second quadrant. Secant, cosine are negative in the second quadrant. So we're going to have a negative square root this time. We're going to have 2 over 1 plus. Now we hit cosine x. So So we're going to think about x. Well, x was in the fourth quadrant. Cosine is positive in the fourth quadrant. And then cosine would be 2 root 2 over 3. We said that before. 2 root 2 over 3. And we're going to do some simplification still, but this is what we immediately get when we use our formula. Again, I want to stress these signs. It's incredibly important we can figure out how to get these signs. We have to make the choice on the outside. That is stemming from what it asked us to find, the x over 2. Once we get to the inside, well, now it's asking for something different. It's asking for x, and so we could have two different positions here. Last thing I'm going to do is simplify, so I need to multiply by that 3 again to get rid of the common denominator. And so we'd get negative square root of 6 over 3 plus 2 root 2. So these are a pair of examples using our half angle formulas. We have another formula for the half angle of tangent. We didn't talk about that one, but you can see that. And in fact, with a half angle for tangent, we see there's 3 different versions. You get to make a choice as to which one you use. Typically, I don't choose that first one because it's got a square root. You have that plus minus decision. It's easier just to avoid it with one of the later two, but you have that choice. You can choose any of the 3. Again, I will stress now we've seen in our formula sheet 2 different places we have those pluses and minuses. The sum and difference, if we have something like sine of alpha plus beta, that is equal to sine alpha cosine beta plus the cosine alpha sine beta. Or if we have the minus, then we use the minus. We are not saying we're using both, we are making a choice. If you're starting by adding angles, you're adding the two different terms here. If you're starting with the minus, you're subtracting the 2 different terms. And then we have the plus minuses occur again with our half angles, so the x over 2, those are the ones we just used. Here, that plus minus again is a choice, but it's a choice based on where the angle is. And I say it's a choice, it's something we got to decide. It's not that we just get to arbitrarily choose it. It's something that we've got to decide. There is only one right answer to choose. We have got to figure out which of those ones is right. We are never going to use a plus minus.